Hello everyone, today, I will explain eye movements. Eye movements are very logical. First, please look at the diagram on the left. This is about the eye movements of the right eye. Looking towards the ear side is abduction. Looking towards the nose side is adduction. Looking up is elevation, and looking down is depression. Next, understanding intorsion and extorsion is important. This is a scope that builds up logically, one by one. As a definition of how the extraocular muscles work, intorsion is the movement of rotating the eyeball from the top towards the nose. Extorsion is the movement of rotating the eyeball from the bottom towards the nose. Personally, I understood intorsion as the movement of rotating from the top toward the nose, and extorsion as the opposite of that. I think the way people understand it may vary depending on the viewer. Referring to the diagram on the right, centered on the center of rotation, intorsion and extorsion movements are made around the axis that connects the center of the eyeball to the center of vision, called the fovea centralis. Elevation and depression movements are made around the axis that traverses the center of rotation horizontally. Finally, abduction and adduction movements are made around the axis that vertically pierces the center of rotation. These three axes are called the fixed axes. The eye rotates around each of these three axes. Eye movements are composed of a synthesis of movements around these three axes. It's okay if you just think, I see, about this. There are 6 extraocular muscles: the lateral rectus, medial rectus, superior rectus, inferior rectus, superior oblique, and inferior oblique muscles. Each has its own role, and they control eye movements by coordinating and antagonizing each other. Next, here is a common table of eye movements. I created this with the hope that by the time you finish watching this video, you will be able to recall everything with just a little memory, or even visualize the eye movements in your mind. First, let's start with the primary actions. The terms adduction, abduction, elevation, and depression are all straightforward from their names, aren't they? The diagram on the right is a top-down view of the right eyeball. Let's gain a general understanding of the arrangement of the extraocular muscles. First, the lateral rectus and medial rectus are quite simple, aren't they? The colors correspond between the table and the diagram, so please burn them into your memory. Next are the superior rectus and inferior rectus. Their arrangement also makes perfect sense, and their actions are easy to understand, right? Then we have the superior oblique, which passes through the trochlea and goes to the back of the eyeball. Intorsion was the movement where the superior oblique pulls the eyeball from the top towards the nose, wasn't it? The inferior oblique, which is colored orange, is attached to the lower part of the eyeball and extends towards the nose. When the inferior oblique contracts, it pulls the eyeball from below toward the nose, which results in extorsion, doesn't it? This produces a rotational force like in the top left diagram. Can you visualize that? You may be curious about the secondary and tertiary actions, but for now, please focus on grasping the general arrangement and primary actions of the extraocular muscles. I have prepared a diagram to help you memorize the complex actions of eye movements. Later, I will explain in detail why these actions occur. However, since some people might find it faster to memorize, I want to share the convenience of being able to recall the actions of the extraocular muscles with a single diagram. First, on the top left diagram, the arrangement and actions of the lateral rectus and medial rectus muscles are clear, aren't they? The superior rectus and inferior rectus muscles have their maximum elevation and depression forces during abduction. So I've added light blue and dark blue arrows in the abduction direction. Also, the inferior oblique and superior oblique muscles have their maximum elevation and depression forces during adduction. So I've added orange and pink arrows on the medial rectus side. Next, there are red circles on the superior rectus and superior oblique muscles. These represent intorsion. The superior rectus and superior oblique muscles are anatomically close, so this should be easy to visualize. Also, there are gray circles on the inferior rectus and inferior oblique muscles. These represent extorsion. The superior rectus and inferior rectus are drawn diagonally. If you focus on the superior rectus and think about it in terms of vectors, its force can be decomposed into an upward component and a medial rectus direction component, vectors. If you also consider the inferior oblique and superior oblique in terms of vectors, and decompose their forces into an upward component and a lateral rectus direction component, You will be able to understand the table at the bottom right. For exam preparation, if you just memorize the top left vector diagram, you'll be able to work out the rest of the actions. I believe everyone has their own methods, but I wanted to share this as one possible interpretation. Thank you for watching. If you found this video helpful, please give it a like and subscribe. Next time, I will talk in detail about the actions of the extraocular muscles during abduction and adduction.